there's two broad categories for use of herbicides in terms of restoration goals. One, of course, would be release trials, where what you're trying to do is promote in situ natives. And the second broad category are restoration efforts that involve replanting. And there the primary focus of our purpose of the herbicide is to reduce or even eliminate the competition, but not have residues of the herbicide in the soil that would interfere with the establishment of the seedlings for the desirable species. So I'm going to talk about one project in each of those broad categories. So this herbicide, the trade name is called Perspective, and it's new chemistry developed by DuPont. And I've been working with Perspective since 2006, not to understand how good it is in terms of killing target weeds, but understand the non-target plant response and its potential use for conservation spraying. So a label became available in 2011 for non-crop use. And this particular experiment didn't start until that year with a new formulation of Perspective, and I'll talk about that a little bit more in the beginning. But the intent here is to use a mid-labeled rate and a maximum labeled rate, look at spring timing when the target is leafy spurge at full flower, and of course that's in late spring, early summer. And then fall timing when a lot of the native plants are in dormant stage, but the leafy spurge may still be growing, or the soil residual characteristics of the herbicide will carry over into the next year within the soil for uptake through the roots and suppress the target species. Then this is new chemistry, and we would want to ask, what is a standard leafy spurge herbicide treatment, particularly when conservation of native species is the goal for the treatment? And that, I think, would undoubtedly be plateau, and this is applied here at the maximum label rate, which is required actually to get good suppression on leafy spurge. This is a replicated plot experiment with traditional Dobemeyer canopy cover type assessments of all the species in the stand. So the Perspective is highly active on leafy spurge. And you can see this is just a photo 2 weeks after the treatment, and you can see the extreme epinasty or twisting of the leafy spurge plant. When we first were working with this chemistry, the active ingredient that is the new chemistry is called aminocyclopyrachlor. We are working with aminocyclopyrachlor alone, and then combined with a number of other different herbicides at different rates. It's very expensive to develop a new herbicide and actually bring it to market. So what the companies need to do is they need to be able to sell this herbicide in as many markets on a global basis as possible in order to recover the development and registration costs, which run in the order of several $100 million just to get a label and begin a sales program. So they decided midway late in the development process to maximize the weed kill, to combine it with the aminocyclopyrachlor, the new chemistry, with a high rate of a herbicide called chlorsulfuron, which you might know as Telar. So this product as formulated and available to buy is 2.5 parts of aminocyclopyrrochlor for 1 part of tellular chlorsulfuron. This is actually a very broad spectrum in terms of its kill. Tellular itself is a very broad spectrum herbicide, and this upped the range of weeds that they could kill with this herbicide as sowed. And as you would expect then, it's going to up the range of species, non-target species, that are injured, if not out and out killed by the herbicide. So this is the trial, and these are percent control data for the leafy spurge. Again, comparing to plateau as a standard conservation treatment, and we have the data now 1 and 2 years after treatment. And you can see in general the perspective at all the rates and timing except for the low rate in the fall outperformed plateau in terms of leafy spurge control. So leafy spurge is very difficult to manage in any way, including chemically. So this is good if your goal is to actually suppress the leafy spurge. This would be a good choice for leafy spurge treatment if that was your particular goal. In terms of effect on overall species richness, we began this trial in 2011 with a baseline sample. We have 2012 and 2013 data. But on the right here is the no-spray controls. And as you see, we went through this 3-year period. There were big drops in species richness. And, 2012 was kind of dry, and 2013 in terms of spring precip was essentially a disaster, especially so on the MPG ranch being in the rain shadow from the Bitterroot mountains. So there's a big drop overall in species richness on our standard, using the standard as a control. But if you look at this is the first year, of course, they're all pretty equal, but you can see that in essentially every case that the perspective was taking species out of the sample size. Now, I'm not saying they're eliminated from the site, but they drop below a threshold where a normally affordable level of sampling intensity will not pick up these species. If you'd walk the whole site that's sprayed, you can find individual plants, but at very, very low values. DuPont was particularly interested in this trial because the ranch has a lot of bitterbrush, and the chemistry had never been tried on a site that had antelope bitterbrush. And leafy spurge throughout the West has a particular tendency to be present in antelope bitterbrush lands. And antelope bitterbrush has high forage value for wildlife and livestock, so they would have been very pleased had the bitterbrush been tolerant to the perspective treatments. But as you can see by the photos, it was highly susceptible in terms of injury. And this was essentially true with all the rates and all the timing. I put this one in here because this is particularly spectacular picture in the way it fell out in the photo. But all the treated plots essentially look like this, including the plateau plots. Bitterbrush was not tolerant of plateau treatment. So here's the canopy cover data. The bitterbrush on that site was running in the 6 to 8% canopy cover range. But with the prospective treatments in the year after, it had dropped down to 2 and 1%. Now, if you look at the second year, you can see that there's recovery. We did not actually kill the bitterbrush as bad as they looked in the first photo. But they still hadn't returned to anywhere near the unsprayed control levels. Now, I'm curious to see this year we should have really good soil moisture, and where the bitterbrush comes back and starts looking more like the controls. In terms of non-target plant injury, you have the direct physiological injury from the initial herbicide treatment. Then you have uptake of the herbicide from the soil in subsequent years, and you have injury and suppression from that for susceptible species. But the big thing what you've done with the treatment is now you shifted the competitive relations between all of the species in that treated plot because they're differential susceptibilities to the herbicides. So often we see cases where species that have high initial susceptibility to the herbicide in the first year post-treatment don't show up in the sample or reduce the very low levels in the sample because you've changed all these competitive relationships and made new microsites available in second, third, fourth year post-spray. A lot of these species, non-target plants that are initially injured, come back into the stand and often will end up at higher abundances than they had before treatment because when you pick the herbicide, you're picking a herbicide that targets the weed specifically. So you're trying to maximize the target plant damage by the chemistry, by the rate, and by the phenological timing. And you can minimize non-target plant damage also by being aware of the phenology. The phenology studies could be used to really interpret when the optimal times would be for spraying for release studies. And one niche I think that's been, in terms of timing, that's not been well used, and it's supported by, I think, the data earlier in the day, is I think we could do a better job for releasing natives by spraying knapweed in August when almost everything else is in drought-induced dormancy, and at least minimize the direct physiological injury. I've been working on this question for about 30 years, and I do have some data sets that support mid to late summer timing as maybe an optimal timing for taking knapweed down and minimizing non-target plant injury. So this is the ordination 1 year after treatment. And for people who don't use ordination techniques in their work, what I'll just point out is that it can be in, you can have actually a rank ordination in one-dimensional space, or it can be multi-dimensional space. Generally what you look for is what's the best fit of the data, and that's measured by a parameter called stress. You can tell how good the fit of the data is and how many dimensions to examine. So in the ordination diagram, each plot is represented by, each point is a plot. And the position of the plot in the coordinate system is based on the overall species composition, every species that's in that plot and its relative abundance. So that 2 points or 2 plots that are close together are very similar, if not almost identical, in overall species composition. And then plots or points that are increasingly further apart are increasingly dissimilar. So when you look at this diagram, you can see the no spray plots all up clustered up in here, and they're distinctly different than the various treated plots. And here's the plateau group down here. It's different than all these perspective plots, which are kind of in a similar area, irrespective of the rate and timing. So yeah, here's plateau, here's the no spray, here's those perspective plots. So that's how you look at an ordination diagram. So this is a mathematical number that's translated into a graph that equates to what standing there at the plot and looking at the vegetation, how it would appear to your eye. And this is the ordination 2 years after treatment. Now you can rotate these ordinations in hyperspace so you get the angle when you view into it shows the clearest separation that you're particularly interested in. And here's that untreated group. Here's that plateau group. We're beginning to get some overlap in those, the untreated and the plateau, but still clear separation from all those perspective groups. So there's another way to look at this magnitude of shift in overall species composition, and we can calculate a number called the ecological effect size. So this is the ordination data and the ordination concept reduced to a single number, but now we have a numerical scale of magnitude on it, so that the shifts that we're interested in are positive shifts from 0 to 1. And the larger that number, the more dissimilar the two treatment groups are. So in this table here, I'm comparing all the herbicide treatments to the unsprayed controls. And you can see pre-spray, there's essentially very small numbers, essentially 0. And you actually can get a slightly negative number is not unusual to show up. The statisticians call this chance-corrected within group agreement. And what a negative number means is it's actually more similar, slightly more similar than you would expect by chance alone, as opposed to being dissimilar by chance alone. The treatment makes the groups more dissimilar. So we get these numbers that in this case range from about 0.2 to 0.3. In my experience, once you get into a 0.2, a 0.3 positive shift, this is a large, not only statistically significant, but ecologically significant shift in overall species composition. So this is a powerful herbicide at the full community level. And Dan and Philip have gone and looked at these plots. You can see this. This is not a subtle effect occurring on the ground. This year we'll go back and look at the 3 years after treatment. Generally, what I expect to see if time goes on, and generally what I do see as time goes on, is the ecological effect size will, relative to the controls, will decrease over time. Here we're still getting big jumps. You see that decrease in the plateau treatment. This is a more typical pattern as the system moves back to stability. Typically it'll take 2 to 4 years for a plant community to stabilize after the herbicide treatment. This community has not stabilized yet. So we also can look at response of individual species. And this graphic quantification is called indicator species analysis. And what an indicator value is it's a numerical calculation of the strength of association of an individual species with a particular treatment or habitat or site type. So the larger the number, the more strongly it is associated with, in this case, with that treatment. And I've scaled these from 0 to 100, and it's a bivariate scatter plot. So on the horizontal axis is the coordinates for the indicator species value for the no spray control plots. And on the horizontal axis is the indicator species value for the treated plots, the plots treated with perspective. The diagonal line is the 1-to-1 ratio of the two indicator species values. The points are the values for the individual species. So points to the right and below the diagonal line, these are decreasers under herbicide treatment. Points to the left and above the diagonal line are increasers under herbicide treatment. These are the data the second year after spraying. And I've gone and I've labeled the species where the indicator species value was significant at the 10% level or lower. So as you would expect, leafy spurge is a strong decreaser under treatment. That was one of the main purposes of the treatment. Here's the bitterbrush, the antelope bitterbrush, the Persia tridentata. But you see a lot of other pretty prominent species that were large decreasers: arrowleaf balsam root, lupine, yarrow, the little jagged chickweed, introduced small annual, Arenaria serpifilifolia, another small introduced annual, salsify. The only significant increaser was cheatgrass, the Bromus tectorum. Not a big surprise, particularly for those of you who are familiar with the overall species competition and across much of the ranch. There were 41 species, 14 were nominal increasers. That's these up here. 27 were the decreasers, and 1 to 10 were the significant levels. Now, if you were spraying for restoration of native plants, you would not be very happy with the outcome of this as a broadcast spray. So what this suggests to me so far is that perspective, the new DuPont chemistry as formulated for the market, its niche for conservation work is probably going to be spot spraying, where spot spraying is feasible and would serve the other management goals of the unit itself. It's not going to be very useful for broadcast spraying at these high rates. And even if your interest is in grasses, perennial grasses, the curious thing here is although we had big shifts in the FORBS to the decreaser side, we really don't see, except for cheatgrass, significant increasers in perennial grasses. Blue bunch wheatgrass falls right out on the 1-to-1 line. Poa secunda is on the positive side, but as an increaser, but it's not significant. But I think it does quickly move into a lot of those little micro habitat. Being a small statured grass, it does well in those micro habitats, but it was not significant. So Stipa comata is down here, and a lot of other researchers have seen perennial grass injury with aminocyclopyrochore at the higher rates. However, I've done 4 long-term trials, and that's not been my experience in western Montana. I'm not seeing visible injury to the perennial grasses, and generally I'm not seeing reductions in perennial grass production, but I'm not seeing an increase. So, from a ranch perspective, if you're going to spray from a livestock forage production perspective, you would hope to have an increase in forage grasses to justify the expense and effort of the treatments. So it's kind of, I don't think perspective as currently formulated is going to have much of a role, if maybe a very limited role for conservation spraying. That's not the case with all herbicides. Some herbicides can be incredibly beneficial if you want to promote native plants. This is a long-term trial with Plateau, or a mathepic, which was sprayed 2 years in a row for the suppression of leafy spurge. And if you look at this ordination, or this indicator species analysis diagram, you see there's about as many increasing species as there are decreasers. Here's the leafy spurge down here. Here's Dalmatian toadflax, which was mixed in with this stand. So this would be a good treatment to consider for broadcast treatment if you were dealing with leafy spurge and wanted to promote as many native plants as you could. But it'd be expensive to go out there and do Plateau at 12 ounces an acre 2 years in a row. A lot of the increasers are composites, and they are particularly tolerant of Plateau. Among those increaser composites is the knapweed. So this not only releases fringe sage and yarrow, but also release knapweed. So that's the downside on this particular alternative. So the Forest Service, of course, is very interested in non-target plant response, and and particularly with spurge and toadflax, because they're so difficult to manage. So we have new trials in progress looking at the mid and high rates on some other site types. One is a post-wildfire site that's going through a tremendous post-burn shrub and forb recovery, so it should be quite informative there. And this time, DuPont says they have no intention of making aminocyclopyrrochlor alone available on the market, but they do have a formulation with 2,4-D. Now, 2,4-D will affect plants when they're actively growing. So I'm working with their formulation of aminocyclopyrin 2,4-D, because for a fall application, it's kind of like just getting the aminocyclopyr alone. And maybe this will have some better conservation value, because we're taking the telar-induced part of the kill out of the equation. And we're looking at this on a site that's dominated by toadflax and a site that's dominated by spurge. And we'll use Plateau as the standard treatment on the leafy spurge site, and telar as our kind of standard comparison treatment on the toadflax site. So this is the Cheatgrass Trial, which will involve reseeding, because of course many of these cheatgrass sites they have little or no remnant native vegetation. So cheatgrass is a winter annual. It germinates in the fall. And almost, if you have late summer, fall rains, 90-95% of the seed will germinate that fall. The other 5 or 10%, some of it will germinate the following spring, and a couple percent, maybe 1 or 2%, might remain viable in the soil through the second and a few seeds into the third year. So the seed is relatively short-lived in the soil. It tends to come out in a big initial flush whenever you first get enough rain after it's gone through the summer curing period. And then you'll have trailing continuous germination of small amounts of cheatgrass. So this is the temperature profiles for Missoula, July through June with the winter in the center. And then Pullman and Bang, Washington. And I plotted these out because cheatgrass is incredibly successful in the Great Basin, Snake River Plains. And the reason it is, it's climatically determined. Being a winter annual, what happens is it gets to the 2 to maybe 4 leaf stage in the fall. Then it gets cold and the leaves stop growing. But every time it goes above freezing, the root extends further in depth. So in the Great Basin, the cheatgrass has the opportunity to put on root growth through the entire winter and early spring. When you get into western Montana, the colder temperatures restrict the amount of root growth on cheatgrass. To me, this is very encouraging because this indicates that cheatgrass should be a lot more manageable under our climatic conditions. And as you go further east, as you get into real continental climate, where the winters are very cold and dry, cheatgrass is less and less of a problem. And it's because it's a winter annual and it's just not adapted to extremely cold and dry winters. So I think cheatgrass is manageable. And over the 30-some years I've been working on this, I've had sites where I've been able to spray out the target weeds, have an initial flush of cheatgrass, first year after treatment, but in subsequent years, the perennial grasses outcompete the cheatgrass, along as the management conditions that led to the cheatgrass establishment are suspended. So I think we could learn to manage cheatgrass in western Montana, but there's a large number of factors, site factors, and precip factors that influence the post-treatment response of these plants, including cheatgrass in particular, but all these other plants to the herbicide treatment. And we have very little understanding and very, very, very little data to support interpreting why some of these herbicide trials are successful and some are not. Because generally we're not characterizing the site and post-treatment environmental precip conditions to the degree that we could begin to assemble a number of case studies to really interpret it as to what would increase our success ratio. So the next generation of people working on this is something I think we need to be making an effort at. So this particular trial uses herbicides, burning, not to get rid of the cheatgrass and not to promote natives. Generally, you can get some effect of cheatgrass reduction by burning, and occasionally you can get some short-term promotion of natives by burning grasslands. But generally, the burning effect is small and transitory and has little effect on, if no effect, on the long-term outcome. But some herbicides, particularly plateau, the amount of litter seems to decrease the efficacy of the herbicide treatment. So there's an incentive to try and reduce the litter in order to improve the herbicide efficacy on the cheatgrass. And then you never get all the cheatgrass with the treatment. And some of your perennials that are desirable may take a longer time to come back and establish on that site, even if you created safe microsites. So working with Dan Mummy, we wanted to look at transitory competitive nurse species, the Clearfield wheat, at least for some of the desirable perennials that we're going to seed into this trial. And we'll do the seeding by drill seeding. Now, if you broadcast seed, the probability of stand establishment is almost zero in western Montana. Between rodent seed predation and the wetting drying cycle in the surface soils being so extreme and poor seed to soil contact, the probability of stand establishment with broadcast seeding is very, very low. The only case where it's likely to work is in a forested area that burned very severely because there was so much woody fuel on the ground. It really created a bare mineral soil surface with a lot of microtopographic release. But I see no success with broadcast seeding in grassland situations in anywhere in Montana. So there's about 14 herbicides, I think there's 15 now, that have significant activity on cheatgrass and other annual grasses. And we picked 6 of them to use in this trial, and then plateau with a burn and a no burn treatment to try and reduce the litter from tying up the plateau. And the rates here vary highly depending on the active chemistry, from about an ounce active to 10 ounces. This is a mixture of, Journey is a mixture of actually of plateau and Roundup, so it has a high active ingredient rate because of the Roundup component. And then there's various surfactant that optimize the performance of these particular herbicides on cheatgrass. And then there's the spray timing issue. Now, generally you have to, overall you have to cheatgrass either before it merges or when it's very young, when the plants are very small, generally at the 4 leaf stage or earlier. Once it begins to develop many more than 4 leaves, it begins to also tiller, grow from the side, and it becomes increasingly resistant to any reasonable rate of any herbicide. So you have to treat it early on. But so that's kind of the general picture in this table. But also I wanted to portray, this is 6 herbicides, and here you see the 4 factors of active ingredient rate, proper surfactant, and the timing of the application. So if you take all 14 or 15 active ingredients and these 4 factors, there's a lot to put together here to optimize the treatment and actually execute it in site. And I would maintain that almost all the cheatgrass treatments that are done are poorly thought out, poorly timed, and probably suboptimal in terms of their potential. Now there's logistic reasons for that also. You can plan the treatment, but you can't always get the helicopter there at the right time. So in this case, the matrix and spike treatments were made in the fall of 2012. And the other 4 herbicides, including the burn, no burn treatment, were made in the fall of last year. And I'll explain why in a little bit. But the matrix and spike treatments were 84 and 88% control 1 year after treatment. I sometimes have gotten into the high 90s with these matrix and spike treatments. But there are some cheatgrass plants that survive. So what we did in the fall then, when we did these treatments, we also retreat these matrix and spike treatments with a low rate of plateau, a rate of plateau that would not normally control cheatgrass unless you had a bare soil field situation. Normally the plateau rate would be more in the 12 ounce per acre. So we'll measure the response, the initial response here this coming year, and there will be no retreatments on those initial treatments. So here's a picture of matrix and a no spray plot, and you can see the purple-red cheatgrass on the no spray plot size, and you can see the general absence of cheatgrass on the matrix treatment. This is the 1 year after treatment. And there's not a lot of remnant perennial grasses on this site. We picked a site with low remnant perennials. But matrix does have the advantage also in western Montana that on fall treatments, the remnant perennial grasses are quite tolerant of the matrix treatments. Under other climatic conditions, they're not so tolerant, but for us, they are quite tolerant. And here's just a close-up then of the no spray on the right and matrix on the left. Now this is the spike, or tebuthyron treatment. This is quite harsh. It not only gets a big reduction in the cheatgrass, but it's quite hard on the perennial grasses. And the main remnant perennial grasses, if you want them. And that's been the main problem with using tebuthyron or spike for restoration is we can't seem to get past the perennial grass injury associated with spike. And here's a close-up again, just showing the cheatgrass down in the litter. This was taken this year, so the plants, last year, so the cheatgrass plants are very small. So the burn, the cheatgrass was 72% of the canopy, absolute canopy cover in 2012. And then it dropped down to 29% of absolute canopy cover last year because of the dry year. But relative to the stand as the whole, in terms of relative canopy cover, the canopy cover of cheatgrass here is in the 90-some percentile. These are real cheatgrass sites. This is Mike and his crew doing a burn for me. So the purpose of the burn was to remove the cheatgrass litter. So we got a significant reduction in cheatgrass litter, but in terms of statistics, but not in terms of meeting the management goal of taking the litter off the site. And I've done 4 or 5 cheatgrass burns, and the idea is that, well, cheatgrass has all this fine upright fuel, and it tends to burn very quickly. And the residence time for the flame is not long enough to heat up the ground. So the flame front moves very, very quickly along, and the litter layer doesn't get hot enough to ignite. So the idea is that you can back burn. You burn against the wind, and that slows the advance of the flame front. And the flame would be there long enough to heat up the ground surface and consume the litter. That's the theory. And it's a good theory, but it's never worked for me every time I've done it. And Mike and his helpers, they made a huge effort to burn this litter off. They burn against the wind, they put a lot of fuel in it. But in terms of the ecological goal, we just didn't really have an effective burn. Where you get an effective burn is when you have cheatgrass in open canopy forest areas where you have a lot of duff and pine needle down. So then there's a lot of fuel, and again you can heat up the soil surface. So it might work for Bert in some of his areas on the elk refuge, but generally in grasslands, there's just not enough fuel there to heat up that ground, reduce the litter. And all the cheatgrass, that's where the cheatgrass seed is, see, right? In July, first week, second week in July, all that cheatgrass seed shatters out within a 10-day period, drops to the ground, so it's below the zone where it can be removed by burning. Oh, I got this backwards. So the replant interval concept, the soil residual herbicide could be injurious to the plant species that you're trying to establish. And we need to know what the replant interval is. So for spike and matrix, in general, the replant interval is a year. You have to wait a year before you would go seed into it. Otherwise, you'll injure your emerging desirable grass species. For the other four herbicides, it's more on the time period of a couple of months. So of course, that's why we do matrix and spike a year in advance. This interval depends on how warm and wet the soil is, because it's the microbes that are breaking down the herbicide in the soil. So it's just an approximation that's influenced by the post-treatment weather conditions. The other factor is that we would know what the replant interval is for matrix and intermediate wheatgrass. We would know it for commercial improved pasture grasses, or some native grasses that are widely used in restoration efforts. But when we begin to get into minor grass species and the FORBS, the native FORBS, we don't know what the replant interval is. That is, we don't really know what the tolerance of that plant is, those native plants are for the herbicide treatment. So that's one of the principal goals of this trial, is to establish what the tolerance to the herbicide, these various herbicide prescriptions is, the desirable species. And that, working with Dan again, we're going to, next week, we're going to seed Anatone blue bunch wheatgrass. Anatone's a relatively new blue bunch wheatgrass cultivar, but it typically takes 3 to 4 years at best to get full germination and stand establishment. And we'd be at risk for the cheatgrass reestablishing on the site in that intervening time, in spite of, with the spike and matrix treatments, having done a follow-up herbicide treatment. So we're going to use the Clearfield wheat as a transitory competitive species to hold down cheatgrass reestablishment, at least for this coming year. Then we're going to try this High Plains Poa secunda. It's my understanding from Dan that he's had really good success. Seems to be well adapted to the conditions and soils on the ranch. And then a mix of thick spike wheatgrass and bottlebrush squirreltail. And then we're going to work with these 3 FORBs, which the ranch has had good success with these FORBs on their site. So that's the 2 trials. And then I just want to go kind of back to the broad subject of herbicides for promotion of native species. So this is another experiment that, and I'll explain it, that has, I think, a favorable outcome and suggested the potential, if we understood the complexity and other site factors involved. This is another ordination diagram, and the stress was 13 is a very good fit of the data. And the red dots are the Mugler and Stewart habitat type definitions for Idaho fescue blue bunch wheatgrass habitat type in western Montana. They went around western Montana back in the 1970s, and they sampled about 500 grassland plots, ordinated it, and the data, and developed what is called the Mugler and Stewart habitat classification system for grasslands and shrubs in western Montana. And so what this gives us is it gives us a quantitative definition of what the natural condition is of a particular habitat type pre-weed invasion era. So all the red dots are the Mugler and Stewart Idaho fescue blue bunch wheatgrass habitat plots. And all the green triangles are a plot on the Sawmill Research Natural Area in the Sapphire Range on the east side of the Bitterroots, a bit south of the MPG Ranch. And the ordination here is that plot in different years. So this is called a floristic trajectory, or an ordination over time in comparison to a reference standard. And what you want to do is drive your would-be restored plot into the hypercloud represented by your reference standard plots. So this is what this diagram is representing. So this is the sawmill RNA, that particular habitat type, the year before it was sprayed. And it was sprayed with Tordon at a pint per acre from a helicopter. This was back in in the fall of 1996. And the second, this is 2 years, the second year after treatment. And you can see a huge shift of the overall plant community composition to the potential natural community. So this would be considered a huge success quantitatively in terms of a restoration effort using a herbicide on a severely weed-infested community. The target was spotted knapweed. Well, there were some other weeds. But then what happens in subsequent years, we have retrogression of the community back towards the unsprayed state. So the one-time treatment did give an initial positive response of some magnitude, but we had regression on time. So there's other factors, part of it being a large amount of knapweed seed in the soil that overcome the 1 year herbicide treatment. And this site has been, at least in the past, severely impacted by elk because of private land exclusion of hunting in the area. And elk are a big disturbance factor on this site. So then in the fall of 2004, right about here, we came in with helicopter again and treated the site with Transline, a rather selective knapweed herbicide. And again, this is 1 year after the retreatment and 2 years after the retreatment. So again, we drove the system towards the potential natural community. So these systems are very complex. There's a lot of herbicide prescription options, active ingredient rate, timing, surfactants, placement. I didn't talk about placement. It's almost like you would have to say, don't try this at home. You really need to up your professional game and understanding of this. We need a lot more data, a lot more case studies to guide us in selection. I would say almost all the herbicide treatment, you know, people want, they want a prescription given to them and they want to go out and do it, and that's it. But it's much, much more site-specific challenge. So that's my talk for today. If there's any questions or comments.